Hello, this is Shang Zhang from Jarena. I would like to talk about the topic on power system transient modeling simulation using integrated circuit. Transient stability analysis, TSA, plays a crucial role in the power system analysis. The traditional method to simulate the TSA is time domain simulation by means of a numerical integration method. So one question arises as whether we can perform power system simulation using integrated circuit simulator with high fidelity while staying computational efficiency. And the second question arises as whether if such a model can be implemented using an integrated circuit chip to mimic power system behaviors. To concept proof our idea, we model the power grid components using commonly used circuit components. Some popular functional block used in control block in power system are low and high pass filters, such as shown here, league-like compensators. These can be easily implemented using circuit components. Nonlinear dependent source circuits can be used to mimic a power voltage or current complex expressions. A unique charging circuit can be utilized in an effort to simulate the integrated block. So with the above mentioned circuit blocks, we're able to deep dive into the power system modeling. A test case of modified IEEE 14 bus system is given here. Some circuit models are listed here. A test case, the transmission lines and the transformers can be modeled using basic RLC circuit components in a pi-shape equivalent circuit. The constant power load is constructed using a nonlinear dependent current source. The dynamics of generators and condensers can be implemented using circuit models, and the associated network interface is based on a Norton equivalent circuit model. The system is experienced a three-phase to short circuit fault through a 0.2 per unit inductor for a time period of 1 second. The fault is realized using a circuit switch implemented at the middle of the fault point. The system takes about 2.8 seconds versus 3.2 seconds against that simulated in Power World simulator using an Intel Core 2.6 gigahertz processor. The results of voltage magnitude, rotor speed, and the power angles of the generators and the condensers shown in figure 1 to 3. It is observed that the bus voltage drop during the short circuit fault and recover after fault is cleared. When the voltage drop, generation power could not fully transmit into the power grid. The unbalanced mechanical power and the electrical power accelerate the generator speed. It takes several seconds after the fault is cleared that the system settles down to an equilibrium point. The dynamic behavior of the system is consistent in terms of bus voltage, generator speed, and the power angle that justify that the proposed power system transient simulation model and approach. The mismatch between the two solutions, as you can see, the dotted line and the solid lines, are mainly due to the model difference utilized by the proposed circuit simulator and the Power World. In addition, different integration method and nonlinear solver are adopted by the two simulation approaches. Specifically, the power angle is essentially an integration of rotor speed whose dynamic performance is not the same, although the trivial to observe. As a result, this discrepancy is enlarged in the figure 3. So to conclude, this paper proposed a circuit model to transient simulation of a complex power system in conjunction with the dynamics of the electric machines and the control systems. This paper is a concept proofing of using circuit simulator for transient simulation, and is a fundamental work to enable a chip to mimic power system and measure power system dynamics on the circuit directly in real time other than calculated by a numerical approach. As an initial practice, the proposed approach using integrated circuit simulators for power system simulation can be extended to simulate the power system electromagnetic transient. So thank you for listening to my presentation, and let's stop here.